Welcome to Real Shanghai Mathematics Practice Book 4.1. This is the second unit, Unit 2, and it is called Number and Quantity, and it consists of 5 parts. The first part is called Understanding Large Numbers. And question 1, read the numbers in the table. So just getting you familiar with large numbers, and the way they've done it is the way you need to know it. So you need to know ones, tens, hundreds, and thousands, 10,000s, 100,000, million, 10 million, and then 100 million comes at the end. And you should be able to read these as well. So shall we do one of them? So for example, 1A would be 1,080,000. B would be 300 million. Sorry, not 300 million, 10 million. 30,070,700, and let's do the last one, which will be 10,100 and 101,010. So that's how you read it, and you may want to write it down there if you wish to, but the main thing is you should be able to read it. To write down the numbers in the table, again, this is the other way around, so 91,080,000 is written as, so you need to write with 91, and they've given you the box there just to sort of help you with it. So it'll be 91,80,000, so 91, then 0, then 8, then 0,0,0,0, so on and so forth. And then question 3, read the following numbers. Again, there's a gap between them, so it should be fairly straightforward. Let's do a few of them. 60,000, 60 million, 3,000, and the other one, okay, it looks like it's gone past. Yeah, so it looks like it's gone to 3,070,504,900. That's what it looks like. Yeah, so they've got billions in there as well. So you can see after the 100 million, which you see in question 1, the one after that would be 1,000 million, and then after that it would be, after 100 million it would be, after 100 million it would have been the billion mark. And question 5 is similar there. Question 6, shall we do Spain? So how would you write that? Yeah, just need to practice those. So shall we read Mongolia? Mongolia would be how many? Mongolia would be 3,100,000. 3,100,000, and then you can put them in order. And then you got writing numbers and the digits. Should we do 7D? Some digit is a what? How many digit number? So I think they just means count the number of digits. So there's 8038. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8-digit number. Highest digit is 8, which is going to be 80 million. First 3 digits you could count from the right to the left mean. First 3 digits 534. The second 3 digits mean they're the thousands, 387,000. Assume that's what they mean. Then moving on to the next one, which is called rounding methods. Rounding methods, which is important to know. Question 1, rounding method. So there you're putting a tick above the nearest million. Okay, so you're rounding these to a million. Write the whole million. Yeah. Okay, so write a million and the nearest one. So if it's past, so the first one has been done. So 6,500,120 is between 6 million and 7 million. And because it's past the halfway mark, which is 6.5 million or 6,500,000, then it's closer to the 7 million. And then we can do the last one, 1D, which is between 10 million and 11 million and closer to 11 million. And then question 2, rounding to the 10,000. So when it's rounding to a million, so for example, when it rounds to a million, then it's going to be 6 million or 7 million or 18 million, 19 million. That's how you round it to. And in this case, when you're rounding to the nearest 10,000, so it's going to have to be like in the tens. So for the first one, it's going to be 19,170,000. So 70,000 is in the tens of thousands. That's where you're rounding it up to. So the next one would be 12,160,000. 60,000. Okay, it's 59,586 divided to 60,000, and so on. And then you've got lots to do in the next page. Shall we pick one? Okay, let's pick the last one, which is United States. So you need to write those out. 376 million. So the 376, and then 400, 400, and then sorry, 474. So 474 thousand. So it'll be 013. So you can follow that. And then rounding, we're rounding to the nearest 10,000, is it? So that's going to be, just to the nearest 10,000, then that'll have to be, so same, starting will be the same, which is 376 million, and then 400, because 474,000, so that'll be 470,000. Okay, 70,000, because 74,000 is close to 70,000, then 80,000. And then you got question 3 to do as well. Question B, a level B, write the missing numbers, rounded it to the, so that what's the number when it's got 38 and the missing thing to 270, rounded to the nearest 10,000 is 380,000. So if it's 380,000, that means the numbers there will have to be rounding downwards. So the numbers there could be 0, it could be 1, it could be 2, it could be 3, it could be a 4, but it can't be a 5, because that would have then rounded up to 390,000. Nearest 10,000, 300, yeah, it would have got to 390,000. Okay, and then question 2 you could try yourself. And then moving on to the next one, which is called square kilometers. Square kilometer. So this is something we have done before. And again, if you first come into this topic and jumping straight to this, you might find this difficult because you haven't done the necessary work to do the previous one. So if you're entirely struggling with this topic, with this year, you need to move this year further back. But as I mentioned lots of times, if you're doing it regularly, then you should be able to catch up. And regularly to me means around 30 minutes every day, or most days at least. And this will ensure that it's not too much for them, so they can still be enjoyable, and also that they can build on their knowledge rather than forgetting it by taking too long. Square kilometers. Okay, so all you do is 72 times 36, and that would be your answer for kilometer squared. Now, if you remember this, okay, so this is meter squared, so that's straightforward as well. So again, meter squared just means this times by this, and you get your answer. So it'll be 54 times by 54, whatever the answer is, then you can add 6 zeros to that. Okay, and again, straightforward times tables. Again, you should know the column method to do that. And we go on to question 2. Write the correct units in the brackets. So just getting you familiar with sizes, lengths as such. So remember, kilometer stands for 1,000 meters. Okay, so area of a top of a desktop is going to be in the meter squared. Okay, it's going to be the meter squared or centimeter squared. Let's think about it. Could be centimeter squared. Yeah, probably a small table. Not probably looks like less than a meter, so it could be centimeters. Oh, it tells you the number 3,500. Okay, so 3,500 would be centimeter squared. Area of blackboard would be meter squared. Rubber is tiny, is going to be centimeter squared. Park is going to probably be kilometers, and so on and so forth. The area of a square cloth is about, so it's not going to be too massive. So it's probably going to be 400 centimeters squared. Yep. And so you're just getting familiar with sizes. Question 3. Write suitable units for each object. So again, units are going to be centimeters, meters, or kilometers. So a skipping rope is about 2 meters. What else should we do? Height of a tree. Okay, so height of a tree is going to be centimeters. Isn't going to be kilometers. That's very very long. So it's going to be 16 meters. Fill in the missing numbers in the brackets. So we have done this before, but let's do this again as a reminder, because I think we just done this once, and it's a reminder for area. You just have to be a bit more careful, because in area you have to do it twice. So which one? Okay, let's do an easier one first, and then we move on to a particularly harder one. So 255 meters squared. Okay, so meters squared. I mean, we want to get it to 100. Into a centimeter squared. Centimeter squared. Okay, so converting meter to centimeter, we have to times by. So we know we have to times by 100 to get into meter. Meter to centimeter is 100 times by 100, and because it's squared, then this is squared. So it's going to be times by 100 times by 100 again. And again, if this confuses you and you can't remember why, you go back to the basic. We've done this before. Remember, the reason for this is because 1 meter. If this is 1 meter, that's the same. So this is 1 meter squared. Okay. If you want to change to centimeter, this will both will be 100. So it's 100 times 100. Okay, and that's why it's going to be 1 and 4 zeros. 10,000 centimeters squared. Understood? And then have they got kilometers here? Okay, kilometers as well. So kilometers, remember kilometers is 1,000. So it's going to be either divide, depending which way we're going, divide by 1,000 if you're doing areas squared. Again, squared just means divided by 1,000 and divided by 1,000 again. So that's divided by million. Or times, depending on which way we're going. Because 1 meter to a kilometer is 1 meter. Sorry, well, 1 kilometer is 1,000 meters. Okay, so hopefully that's useful. Again, some of these things, first step should always be, is the number bigger or smaller? So we've done a few of them already. Let's go with 4B. Which one shall we choose? Let's choose 960 million meters squared. Okay, so meters to kilometers, we know meters to kilometers, the numbers are going to be smaller because 1,000 meters is going to 1 kilometer. So it's going to be smaller. And because it's squared, then it's going to be divided by 1,000, divided by 1,000. So we're getting rid of 6 zeros. Okay, and the rest you should be able to do yourself. 5A. Okay, so if you get it right, so that's a question about adding different units together. So to be able to add units together, 5 meters squared plus 4 centimeters squared answer centimeters squared, you need to have all the same units. So here obviously easiest going to be change the 5 meters squared. So 5 meters squared will become how much? 5 meters squared in centimeters squared is going to be 5 times 100 times by 100. So you're going to add 4 zeros to that. So 50,000 and be 50,000 divided take away for B. Take so the first one would be take away 4, and there's your answer. And the other one is going to be 50,000 if that's what I said. Take away 40, and so on and so forth for C and D. Take away, yeah. And then question 6. Let's just do 60. Area of a classroom is about 400 meters squared. Yes, that could be right because each length could be one could be 8, the other one could be 5. 8 times 5. So 8 times 5 is around 40. So this is a very, very large classroom, potentially. Okay, large classroom size, what then? Okay, it's a tricky one. Perhaps feasible, could be. As I say, 8 by 40 meters, 40 meters long classroom. Be very large classroom, so maybe not right. Maybe 40 would have been right. So as I say, it's more about knowing the applications and being comfortable with that. Let's do 7C. Every 20 square meters of trees in the forest can absorb 80 grams per year of harmful substances. How many grams of harmful substances can the trees in 380 square meters forest absorb in a year? So you do 3,280 divided by 20. So that'll give you those how many of those squares there are, and then we can then times that by 80 because that's how much 80 grams in every 20 centimeters 20 square meters will be absorbing. So we've got level B practice. That's an look around, estimate each area. So that's optional for people. Again, length of rectangle is 6 meters, the width is 3 meters. How many 4 centimeter squares can be cut out of this rectangle? So you can play around with that. The rectangle, the width is 3. Okay, and then see how much you can do. I mean, the way to work it out, one of the ways to work it out would be 6 times 3 is 18. How many 4 centimeter squares? Well, 14. 4 fours are 16. How many of those? But sometimes these practical may be important because they show you that you can't maneuver them in a different shape to be able to take them out. And again, 3 is optional for you guys for level B, which is page 24. And then moving on to the next topic, which is the last second from last, which is called understanding tons. Understanding tons. So a ton, very large amount, is 1,000 kilograms is a ton for this purpose. So the mass of the truck would be about 3 tons. Okay, the other one gram is very small. So from centimeters, now we're doing weights, mass, which is to do with kilograms or grams or tons. Grams are very small, like a rubber, and kilograms are heavier, like a bag, and a truck is humongous, so like a ton there. Fill in the missing. So again, 37 tons is going to be 37,000 kilograms. 37,000 kilograms. Let me just double check that. Okay, so let's do 66 tons. How many grams? So that's going to be 66,000 tons. Okay, very large number. So you're gonna have to times it by 1,000, which will give you kilograms. Which is, so you add 3 zeros, then if you times that by 1,000 again to give you grams, so that's gonna be 66. You got 63,000 has 3 zeros in there. Then you're gonna add another 6 zeros. And then calculations again, you need to keep with the same unit. So the 58 kilograms you need to change to tons, which is 58 tons, and so on. And again, 47 kilograms take weight, 32,000 grams. Again, the units have to be the same. So convert the 47 kilograms into grams. So that'd be 47,000 take weight, 32,000 grams, and so on and so forth. Read the following for A. There are 66. Okay, let's do another one from there. 4D. A factory has 40 tons of coal. 10 tons have been delivered already. How many more days will it take for the rest of it to arrive if tons are delivered per day? So has bought 10 tons already, so we need to have another 30 come. And if 5 tons are divided every day, it will be 30 divided by 5, so that will be 6 days. And question 5, you can try that yourself. Question 6, again, greater than or smaller than, it should be straightforward. Just remember the units, so 6,500 kilograms is going to be 6.5 tons. So remember, divided by 1,000, we've done this before. Move the decimal place back by 3, and the decimal place is at the end. Okay, and again, we'll focus on practical ways of doing it rather than actually being accurate in terms of what I'm saying. And question level B, which one shall we do? 1D, so that's 10,700 grams. So 10,000 is going to be 10 kilograms, and then you've got 700 grams left. And then you can order the following, and for order, if you're getting confused, then try and put them all in the same units, and that should help you with it. And that's for level B. And 3, again, you can try. As I said, level B's are a bit more optional, although some of them are reasonable. If you're very stuck on them and you're really keen on doing them, then let me know, we can do them. And then the last one is moving on to milliliters and liters. So we've done lengths in terms of meters, kilometers, centimeters, and you remember there's also millimeters, although I'm not sure we've done it this time around. Then we've done mass in terms of kilograms, tons, and grams, and now you're doing volume, which is in milliliters and liters. Okay, so 1,000 milliliters makes a 1 liter, the same way 1,000 millimeters makes 1 meter. So a goldfish bowl holds a milliliter is very small amount, and you understand that. You understand that. So a typical bottle of drinking water is around 1 liter. So just get your head around that. A goldfish probably hold 10 liters of water. A bottle of juice will be 450 milliliters. Again, 150 liters is a very large amount. Carton of milk, again, milliliters, and so on and so forth. And a soft drink, milliliters, the symbol for that is ml. So that would be 2A will be A. And then you can do the other ones, which look like straightforward. Question 3A, just a reminder again, 63 liters to milliliters. Think bigger or smaller. Remember, 1 liter is 1,000 milliliters. So then it's going to be 63 times 1,000. You're just adding 3 zeros. And 9 liters equals 9,000 milliliters. And 20 liters will be 20,000 milliliters. And then smaller, greater than, and fill in the missing numbers in the brackets. So again, need to get the units the same. So in this case, 6,000 mils and is going to be the same as 6 liters, and the 6 plus 7, and so on and so forth. To do with that. And 5, shall we do 5C? There are 3 liters of water in a bottle. 1 glass can hold 250 milliliters of water. How many glasses? So how many glasses can you pour? So if you think about that, every time you're going to be losing 250. So how many times you're going to lose it? So it's to do with timings. So it's going to be division. But you need to get the units the same first. So 3 liters is the same as 3,000 mils, and then 3,000 divided by 250. You can get rid of some of the zeros if you know what you're doing, or you can just use the bus stop method and do that way. And then moving on to the last bit, which is level B, order. And again, order, make sure do them all in the same unit. So I would suggest 8 liters, 88 mils would be 80. That would be 8088. The other one's also 8088, and 8 liters and 8 ml would be 8008. And okay, so the first one is 8088, the other one is 8080, and the last one would be 8888. Now you have the numbers, then it should be easier to order them. And then question 2, try that yourself. And 3, 500, the school has water, hold 19 liters water, drink water. If each pupil drinks how many containers of drinking water must the school order for each day? If each pupil, so how many pupils are there? 500 pupils, okay? 500 to be 500 times by 400 mils. That will give you about the amount of liter. That will give you about the amount of liter they are, and then you can divide that by 19 liters and work out roughly how much you need. And with that, we end this unit and moving on to unit 3. Thank you for your time, and please like and subscribe and share.